Yes, we can hear you.
Okay. Okay, wonderful. Hi, my name's Sam. I'm a resident of Havertown, and it's wonderful to be able to talk to you and collaborate with Steve on these presentations that we've done multiple times in the past. And my part of the presentation deals with my personal experience on electrifying my house and the steps that were involved in actually undertaking this process. And for most people, it is a process because there's so many things that are involved in completely electrifying your house because there's so many different appliances and that are part of our daily living that can be transformed from fossil fuels into pure electric, and from being electric then can be used to be powered by non-fossil fuel means such as solar or wind or our increasingly greening grid infrastructure. So with that introduction, let me tell you a little bit about myself. My motivation for this is pretty simple. I am a very strong environmentalist. I believe that it's important that we do our bit in order to mitigate the effects of I'm sorry, I've got a lot of cats in my house. I think it's important we mitigate the greenhouse effect by doing as much as we can at a personal level, as well as and since I've done everything I can at my own personal level to then expand it to the people that I can educate through these types of talks. So first of all, I want to explain that I am a union sheet metal worker. I'm with Local 19, and I got a lot of experience as an HVAC installer with commercial ductwork. So I transferred that experience into my own household. And I do that by doing construction and being able to, I'm sorry, I have to relocate. One second. So I have a lot of construction experience, and I can translate that into the stuff I do at home in terms of electrification. I'm very sorry about that. So I have experience installing heat pumps on a professional level, as well as all the other construction mediated things that go into this process. I've learned during my time as a union construction worker. I also have a very tolerant wife who had the patience to allow me to do these things, in my own house. So I give a lot of thanks and kudos to her for allowing me to do these things. So next slide. This is my house. And it's an average twin house in Havertown. We're at the intersection of Route 3 and Route 1. And we're right behind that Burger King you probably pass every day on Westchester Pike. The thing that a lot of people don't seem to understand is that you don't have to have a special house to do these types of things. The house that you see in this picture is the same house it was before and after full electrification. A lot of times there's this preconceived notion that houses that have a very strong environmental bent have to be special or have a unique look, but really the before and after of this process of going through full electrification is nothing special in terms of the aesthetics of the house. It's only with the mechanicals. The way you heat and cool your house, the way you heat your water, the way you dry, the way you wash your clothes, the way you cook your food. It doesn't require massive changes in your house, just the basic mechanicals of your house that you use every day, but are sight unseen until you actually replace them. So I think that's important to understand. So if you drive by my house, you'd never know that it was anything different from the neighbors. So next slide. This is my backyard. Uh, what's hard to see is that on the garage in the back, right in the center, is a 3.6 kilowatt solar array. We actually, my wife and I installed this first during our process to fully electrify our house. And we did this through Delco Solarize. It's a wonderful program, and I encourage people to take part of this wonderful incentive that Havertown offers to its residents. If you wish to put a solar array on your house, they bundle all the people that are interested in having their houses solarized, and they send it as a bundle to contractors in order to incentivize to get a lower rate and also to get a lower interest rate for the installation of the solar array. We went through Lumina Solar. I believe they still participate in Delco Solarize. And they did a wonderful job installing the array. It only took 2 days. And the only real problem was the actual hookup to the grid, because we have a grid-tied system. So it took a little time to get that done through Pico. But overall, the sun provides about a third of all the electricity of our house. And you also have to remember that our entire house is solarized, and we also have an electric car, so we have a pretty high electrical need. And we also have a tree nearby, which shades our main house, which limits the size of our array. So considering the amount of electricity we consume and the efficiencies that we undertook in our house, this is actually a considerable amount of electricity that is provided by the sun, which is a wonderful thing. And another thing is that the loan that we got and the incentives we got through the federal government, which were a third of the cost of the array installation and the materials and labor, was covered by the federal government's by the federal government. So and the total monthly cost would be the amount that we ordinarily would have paid to Pico anyway, from just taking the money, taking the electricity from the grid without solar. So I think of it as a one-for-one swap, and we're much cleaner for it. Next slide. One of the big things that you may need to consider when you completely electrify your house is the possibility of needing to update your electrical panel. Think of it as a river that comes into your house. You have a river of electrons coming in to supply your electrical needs in your house. We had a 100 amp service, and I decided to upgrade to a 200 amp service in order to provide the needs of all the electrical appliances that I have in my house. You may not necessarily need to upgrade your electrical panel. You want to take a look at that possibility with a qualified electrician, or you can take advantage of any number of calculators that are online to see whether your electrical needs will require an upgrade to your panel. So that may be something to consider as you're going through this process. It's also worth mentioning that the federal government, through the IRA, the Inflation Reduction Act, provides incentives to upgrade your electrical panel if you so choose to do so. Next slide. So one of the things that is the crux of our presentations is heat pumps. And Steve's going to go over the physics of heat pumps. But just to be very brief about it, a heat pump is nothing but takes advantage of the fact that you have a refrigerant, and that refrigerant cycles through two components of what is essentially an air conditioner. You have a condenser, and you have a distributor, a terminal that distributes the cooled or heated air. So it's mainly just a transfer of heat. In the summer, you're transferring the heat from inside your house and dumping it outside of your house. In the winter, you're taking ambient heat that's in the air outside, which you may not think there's heat, but there is, and it's taking that heat and transferring it from outside and dumping it inside your house. And that's what essentially I've done with my house. I removed all the radiators of my house and replaced them with mini split heat pumps. Mini splits are a terminal-based heat pump that has these little heads that you see on the left. And when you operate them, they either cool or heat your house, depending on the season. And I have 3 of them, one for my basement, one for my first floor, and one for my second floor. My basement and first floor are open concept, so I just need to have the head, and I have it centrally located in the basement and the first floor. And on the second floor, when I redid it, I ducted it. You can actually have a ducted heat pump, and I ducted it through all of my various rooms in my second floor when I did the remodeling for that for my house. I might also mention that when I went through this remodeling process, I insulated the house as well, so it would decrease the size of the heat pump that I required for my house. So it also increased the efficiency of my needs and decreased the electrical needs I needed for these heat pumps. Next slide. You can also have other locations for heat pumps. One of them you can have is for your dryer. Your standard electrical dryer just has what you would call a toaster element. If you look inside an old-fashioned toaster, you'll see those little coiled up electrical components that glow bright red in order to heat to dispense heat and heat your toast. That's essentially what you have in a dryer, an electrical dryer. You have a heating element that glows hot red, and you blow air over it, and then it goes ahead and dries your clothes. But in my dryer, I have essentially a mini heat pump that takes the heat from outside of the unit, draws it into the unit, takes that heat, and essentially dries the clothes. And the other, and it uses a third of the electricity than a standard electrical dryer has, that has those heat coils that I told you about. And it's much gentler on your clothing because you don't have it's not as harsh. It's not as intense of a heat, and I haven't had any problems with it since I purchased it about 3 years ago, except for a broken what's it called? I'm having way too many senior moments as I get older. The tumbler, the tumbler strap broke, and I had to replace that, but nothing major. And they do sell them now in the United States. I saw actually one down at one of the big box stores, either Lowe's or Home Depot. They do sell them now in the United States. This is a German model from Miele. Next slide. And I also have a heat pump water heater. This is a model from Australia called Sandon. Unfortunately, you're not going to find these at your big box stores, but it is essentially a heat pump. The same concept is I'm drawing heat from outside. On the left is the condenser unit that draws the heat in from underneath my porch. And through water lines, it dumps that heat into a stainless steel tank, which you see on the right, heats the water, and then distributes it through the house as needed. And I've had this unit now for about 2 years. The unit itself cost about $4,000 when I purchased it, but I did all the labor myself. In fact, all the things that you've seen previously, I installed myself. So it saved a considerable amount of money for the installation and retrofitting of my house. and I was able to, but I wasn't able to take advantage of the tax credits because it still didn't exist at that time. But hey, it's a wash. Um, and I think there's a warranty on this for 10 years. And they do sell heat pump water heaters in the United States. They have tank units with the heat pump on top. So you're drawing the heat from, say, you have your unit in the basement, it'll draw the heat out of your basement. So in the summer months, it's good. In the winter months, it's probably going to be a little more difficult because you're cooling a room in your house that is already cold due to the fact that it's winter and it's making it colder. So these units are a difficult sell in colder parts of the United States, which is why I went with the Sandon model, because I can heat my water in the winter from ambient air from outside rather than ambient air in my basement. So that's why I went for this model. Of course, I had to do a lot of research to find this. And if you want to do it too, I can give you information on how to do it and where to go in order to get this model. But that's for another day. Next slide. Last but not least, this is my stove. I have an induction stove, which is electric. And of course, this has nothing to do with heat pumps, but it is part of the electrification process in my house. It was the last thing in my house, aside from my car, that was the end of my use of fossil fuels. An induction stove uses the process of magnets of the process of using magnets to cook your food. You do, and I'll go into the physics of that with the next slide. So essentially what you're doing is, I'm going to read this verbatim because I really haven't prepared too much, but I do like these slides, that energy is transferred directly to the cooking pan through a magnetic field. You're essentially causing vibration of the magnetic portion of your cookware in order to produce heat. It's really, really fast. When I turn on the stove in order to cook my oatmeal in the morning, I can boil water in no time flat. And it's a wonderful, wonderful process that doesn't involve the burning of fossil fuels, so that I don't have any VOCs in my house. I don't have any additional collection of nitrous oxides or carbon dioxide in my house as well. So it makes for a nice, clean, efficient cooking environment, which is absolutely wonderful. And I couldn't ask for anything better. And for those people that remember way back when they said, now you're cooking with gas in those old commercials, they might as well be saying, well, no, now I'm cooking and choking myself. And now I'm no longer doing that. And really, it's much more efficient, and it doesn't require methane. And methane is the principal natural gas that is used when using a gas cooktop or a gas stove. And the process of drilling for it and transferring it to your house, and then having it being released from your stove, unfortunately, there's lots of leaks that are involved, and methane is a very potent greenhouse gas. So for anybody that thinks that gas is efficient and is a good method of cooking your food, when you're using it, you're contributing to the greenhouse effect in a disproportionately large way compared to any other appliance in your house. So that's something to consider when you're considering changing from gas to induction stoves. Next slide. So these are probably things I've already indirectly talked about. When you switch from gas to electric, you're reducing the carbon dioxide which is burned, and also the methane that's released from your stove passively. I didn't realize this, but 75% of methane leaks occur when stoves are off, which not only is very bad for the greenhouse effect, but just downright wasteful. Gas stoves emit harmful VOCs, which raise indoor levels above established health benchmarks. I do know that they contribute to asthma as well. And formaldehyde and benzene are carcinogens. And well, they're not good. I already mentioned it boils water faster. You have less heat in your kitchen, which is especially good in the summer. And yeah, my cooktop is very easy to clean. I just spray it with Windex, wipe it down, no problems whatsoever. I guess that's really about it. Next slide, if there is one. Oh yeah, there's a variety of different price points for stoves. I remember when I was looking up which type of stove to get. Oh God, they range from in the low thousands upwards. I found a model that was up to $6,000 or $7,000, and they can have all the bells and whistles. It's insane, but as long as it's induction and it fits your needs, there's really no need to go beyond beyond those particular needs for your induction stove. But if you want to look up various reviews, there was plenty of stuff on YouTube when I was doing this type of research. And ultimately, I got lucky. I found a guy who was selling one for half price because, I mean, really, he said he didn't have an air fryer in the stove. And all I was looking for was the induction capacity, and that was fine with me. So I guess that concludes my portion of the video.
So I'm just going to chime in to say that the Inflation Reduction Act has a lot of incentives and different discounts. Some of those discounts have not come into play yet. So for induction stoves and ranges, you can get up to $840 towards your range in the future. So this is going to be administered by the states, and the estimate is that it's going to start in 2024. It's income dependent. I can tell you that I put in my income, which is probably upper middle class level, and we were considered middle income. So we would get 50% of the amount of the range back up to $840. If you're in the low income category, you get 100% up to $840. Obviously, we didn't see any that were $840, at least, from a store that might be giving that direct discount. So that gives you an idea. And you can find this information of all the different incentives, savings, and all these different things at rewiringamerica.org. And an easy place to find that is on our Haverford Climate Action website, haverfordclimateaction.org. And there's this icon with the piggy bank. And if you click on that, that will take you to the calculator. So for your income level, you can find what your savings are. And I just wanted to say one more thing about the induction stoves is there's a lot of climate actions that are money saving. Changing your stove and out is generally not a money saver. It's something that you would do for other reasons. And the reason is because even though it's so much more efficient, you're not using your stove that often, so that you don't get the financial benefits back. And I'm going to invite Hank in to talk about the next slide.
Sorry, I was muted. Okay, can you hear me? I'm sorry, I was muted. I thought I would just add this to the mix as Sam sort of explained how it works, and he mentioned about getting a full range. And what we did is we have a little bit larger of a range at home, and It's a dual fuel, actually. It's a gas cooktop and electric oven. But what I wanted to do is we installed sort of an outdoor kitchen, a countertop, and we sort of went with a portable unit for two reasons. The first is to get acclimated to learn, does the induction have the same control as the gas? Because that's the appeal of gas, is that as a cook, you really have some fine control of the heat that you apply to your pot. And that has proven itself that you do need to get used to it, but it doesn't take very long. So it's the size of your pot and what you have in it, but you can really finely control, just like you can with gas. And probably, as Sam mentioned, it's actually faster reaction. So the heat comes faster and you can turn it down faster. You have a much better, we found that we have a much better control on like even a simmer. We also on our gas range have a power burner, so it's a big gas burner. It's really meant to heat up a big pot of water pretty fast. And so I did a timing test, and the induction burner, actually it was a tie. It came in at the same time to heat up a big pot of water. So I give it a lot of credit for that. And the second reason we got it is, as I mentioned, we sort of put an outdoor counter outside. So it enables us to cook out there. We tend to use that, a barbecue, a steamer, and a crock pot and a toaster oven outside during the summer months as much as possible to really keep the heat out of our kitchen and our house. So anything you add to the house, you're going to cool it out with mechanical cooling. So I just wanted to say this is another option. This is about $125 unit. And it's really lightweight. It's not heavy at all. You can pick it up with one hand. So it's another option if somebody doesn't want to put 2 feet into the pond yet and go, replace their existing unit. You just want to get acclimated to what it is. It's another way to go and whatnot. So,
and one thing that was on the slides that we didn't specifically say is that because induction works by magnetism, you do need to have magnetic cookware. So that if you don't already, which you could just put a magnet to it to find out, that might be an additional cost if you are making the switch. And just
Right.
one other thing is these little one burner things. Some of them are designed for just kind of heating, like if you put out a buffet. So you just want to make sure that you're getting a power, and the power is by the wattage. So that's big enough. And actually, where the state of Pennsylvania right now has an incentive for commercial institutions, commercial kitchens to switch to induction, and their incentive is up to $8,500. And we're actually, from our church, we're looking at some of these countertop units.
Yeah, when I purchased this unit, you can actually get this unit in a 2-burner setup also. But this will heat. It's not just warming, as you had mentioned, Joy. So this will do cooking, and I think it's probably an 1,800-watt unit and whatnot. And then the nice thing is you can use it just for warming also. So if we're entertaining, we can throw it on the kitchen table and put something on it. As far as the pots are concerned, we had like maybe 2 items that wouldn't work on it. We replaced them. So if the pot's completely aluminum, that will not work. If it's a copper bottom, that won't work. But as you said, the easy trick is just to put a magnet on the bottom. If the magnet sticks, it'll work. Cast iron works great. So I know that was something a couple of people would say, well, what about cast iron and whatnot? And it works great. And we have like a Dutch oven that's cast iron, and it fits on the unit really nice and does a great job. So,
one other thing, I don't know if you guys have mentioned it, that is an advantage. It's also very safe in that you can put your hand on the burner when it's in cooking mode. And I think Sam has a picture, which we couldn't find in time, of his cat sitting on the top of the range. And it's my cousin's father is suffering through early dementia, and leaving a stove on, especially with the gas on, and having the danger of someone getting burned is always a concern. So they replaced the top of the stove with units just like these, to just eliminate that. He could leave this on, it'd be no problem at all. You wouldn't have the gas, natural gas explosions concerns, or you wouldn't have the concerns of being burned. So that's just another
Yeah,
plus.
it's pretty safe. In fact, this little unit, I'm assuming Sam's works the same. If you take the pot off, it recognizes it, and it shuts the unit down. And it gives a timer. So if you take the pot off for like 2 seconds, it'll cut the power to it, but you put it on, it'll resume. But if you take it off for such a long time, it just cuts itself off. The surface will get warm, because the pot is the thing that gets hot, not the surface, but the surface will get some of the heat off of the pot. So it's not, I wouldn't put my hand on it. But the other thing is, as Sam mentioned, they're very easy to clean, because on a traditional electric cooktop, even the glass is getting extremely hot. And when anything spills on it, you're basically baking the stuff on the glass. In this case, you're not. So it's much easier to keep clean too, because you're not baking your food on the top surface. So real great advantages on that. So and actually, they're starting to sneak in. I was away this past week in upstate New York, and the hotel, when they had their kitchen buffet, all the stuff, actually they had built-in induction burners right in the countertop. And you can tell that they're very safe. They're not getting hot, but the pan is kept hot. So they're starting to sneak in there, and it's not real obvious unless you look that that's the technology they're using. And as you said, Joy, I know some of the commercial kitchens are starting to utilize some of this induction, because it's very flexible for them.
Awesome. So should we move on? Do we have any questions? Should we break for induction questions? So we're going to go to heat pumps. Is there any questions? No. Okay. All right. Thanks, everybody. I'm just going to continue. This slide here, my name is Steve Clark, and I'm an engineer, and I support New York State's heat pump electrification effort. I do engineering for the utilities who promote and give incentives for electrification up there. And so this is an overview slide. I know it's, like as Sam probably insinuated, it's a lot to think about. There's a lot of things you can do to electrify your house. And here I'm trying to put it into some kind of context. Here are things we've all heard about: solar, electric cars, heat pump water heaters, heat pump dryers, induction, electric yard equipment. And they all have different carbon impacts, and they all have different costs and complexity. And I've tried to simplify that in terms of the carbon impacts in terms of a tree. So these three things, solar, electric cars, and heat pumps, have by far your largest impacts on your carbon and environmental footprint. They're also the most expensive, and heat pumps are probably more complicated than these two, getting an electric car or getting a solar panels. And I'll try to go through some of the most important things in the time we have left. Then we have these middle tier here things where it may, and so this could cost between $10,000 and $30,000 or even $40,000 or more if you have a more expensive electric car to do these. So these are tens of thousands of dollars to do these typically. Down here we have things that are several thousand to $10,000, but say around $5,000 mid-range-ish. And heat pump water heaters would save a moderate amount of carbon. And as Sam mentioned, induction stoves, it's going to have a modest impact on your carbon footprint. Stoves don't use, of any type, don't use much energy, period. Same thing with clothes dryers. We just don't use them that much. And then finally, at the bottom, we have electric yard equipment. And these are the cheapest, whether we're talking about electric blowers, electric lawn grass cutters, clippers, all those things. They're the cheapest, but they also have modest. But these also have really strong other effects. They're very quiet. They don't have the pollution. You don't have to store gas. And I just heard that Home Depot is going to have 85% of its inventory of electric, all types of stuff by 2028. So they're moving, everything's moving really quickly. So that's just an overview of all these different things. And we're gonna talk about the most complex thing here, heat pumps, right, for the rest of this talk here. And here's just another resource that talks about a lot of these things, the Zero Energy Project. Sam did mention looking at your panel. If you look at the top, your main breaker will have a number on it. If it's like mine, an older house, it could have 100 amps. Most people recommend you have 200 if you're thinking about electrifying your house. And there are some good resources here on whether you need to do that or not. And most of the times you don't need to upgrade it. But it should be done logically, and it should be done in some systematic way to make that decision. So what is a heat pump? Sam mentioned at a high level, just moves heat from outside your house to inside or vice versa. And one way to think about this is to use this analogy of water. So a water pump, water will naturally move from high to low elevation spontaneously. But a water pump can, if you add energy through the pump, can move water backwards, essentially from low to high. And heat pumps it's really the same thing. Heat will always move from warm to cold. There's no such thing as cold in physics, it's just the lack of heat. And there's heat down to negative 460 degrees. So even though it's very cold outside, maybe 0 degrees, there's plenty of actual heat outside your house that can be used to heat your house. A heat pump will move heat backwards from cold to warm. And to do that, it needs electrical energy. So this is just a schematic of water. This could be like a dam. Water would naturally flow this way, down. But if you have a pump, you can pump it back. You can think of the same thing with heat. Two common heat pumps are ACs and refrigerators, and they always move heat from the colder side to the warmer. And heat pumps just can change the direction. That's all it is, really. One common misconception a lot of people have is that heat pumps don't work in cold weather. And that was true maybe 10 or 15 years ago, but it's not true at all. The technology is absolutely exploding. If you are serious about looking into heat pumps, you should look into this resource. This is the Northeast Energy Efficiency Partnership, or NEEP. There's a listing of heat pumps rated all under the same way. And they have to have at least 175% efficiency at 5 degrees outside. So that's pretty amazing if you think about it. The toaster that Sam mentioned, if you turn on a toaster, just a regular coil, it has 100% efficiency. And most furnaces and boilers are about 80% efficient. So this is the minimum efficiency to be accepted into this listing. And actually, as of today, there's 107,000 models listed in this database. there is now this button here, eligible for federal tax credit. This is active. So if you go to NEAP, you can check north, and you can filter by, and you can find heat pumps that are eligible for the federal tax credit. If you are working with a contractor, always tell them you want a heat pump that is listed on NEAP. And then you know it's been tested, you know it goes down to cold temperatures. You know it's going to be an efficient unit. This is an example of the data that comes from it. I think this is actually the one Sam has. It could be wrong. But it has important engineering data, like how much heat can it put out at 47, 17, and 5 degrees, and now they're going below 0. Many models are rated at -10, -15, but you can see that the efficiency is also given here. At mild temperatures, they're about 250 to 400% efficient, which is pretty good because that's where it's going to operate for most of the winter. Whereas your gas range or gas furnace or boiler is going to be about 80% all winter. These, for most of the winter, they're going to be at this around 250, 350% efficiency. But one of the things you notice is as it gets colder, the efficiency goes down. It's harder for the heat pump to pump in heat from outside when it's 5 degrees compared to, say, 45. And the power that it can give goes down. So you have to make sure that, and your installer has to make sure, and you have to be confident that it'll keep you warm on the cold day. I'm just going to go over the different types of heat pumps. Most of the heat pumps we're talking about today, and most of the ones you'll see, are air source. So the heat, this is an outdoor unit here, kind of like Sam's. It moves heat to and from the outdoor air into the house. And in this case, there's ducts everywhere. So if you have duct work and you have an outdoor condenser and an indoor furnace, it is the easiest situation to retrofit. If you're coming off of a fuel like oil or propane that is very expensive, I think you'll be pleasantly surprised. You're going to save a significant amount. If you're coming off of gas, it's probably going to be a wash, maybe slightly more expensive. Maybe you'll make out a little bit. It's not going to matter much in terms of the amount you pay Pico for or for fuel, period, if you're coming off gas. But if you have one of these outdoor condensers and you have ducts and you're using a fuel like oil or propane, you will be pleasantly surprised. Another case is it's the similar outdoor unit here, but there's no ducts, so they have these indoor cassettes, and these are called ductless split heat pumps, and those are the kinds that Sam mentioned. He has these units throughout his house as well. Finally, we have ground source heat pumps, which on the inside is very similar, but the outside we have these loops moving water with a antifreeze in it that really exchanges heat with the ground. So in the summer, it's dumping heat into the ground from the house, and then it reverses in the winter. And these are the most efficient, but obviously the most expensive and more complicated to do, because there's often multiple trades. There's people that do the drilling, and then there's people that do the all the HVAC, but it's also very popular. This is, excuse me, an example of utility bills for a member of our EAC that went through a winter. And we compared how much gas that they use. So here you can see, this is with the gas furnace system. And then they switched over, you can see the summer, this is probably, this gas is probably cooking, but mostly probably domestic hot water. And you can see what what I think they switched over in the fall here. You can see the absolute drop off of gas. Even though it was getting very cold, electricity use did go up. You could see in the cold months here, the electricity went up significantly. But when you compare the costs, he came out slightly positive, about $200 a year, but it wouldn't be a motivating factor for you to consider to go to a heat pump just to save cost. If your furnace is old or not working, it's definitely a good idea to do this. Joy mentioned the Inflation Reduction Act. Here's and again, this is a great site to bookmark. It's got a lot of resources beyond just the Inflation Reduction Act. Here are some of the things that are eligible for different things that you can do. They may not all be incentives might not be available for all of these yet, but it seems like maybe next year things are going to be rolling out. That's what Joy, do you have any insight into other things beyond induction?
I just on the Rewiring America website, most things it says 2024. But I would have to cross my fingers for it to be early 2024.
Right. So that's a good time to think about this stuff again, especially in terms of heat pumps. If you have a central air system, especially if you have oil, or if your system is old. And when we say old for HVAC, something about 20 years is getting near the end of its life. And you should be thinking about preventatively changing it before you're stuck in, with a cold house in the January. It's no different than a car. When you go up, your car is getting up around 120 or 120,000 miles. You should be really starting to looking. And the same thing is with your house and your HVAC. As you get up, certainly over 15, 20-ish years, your water heater, that's the time to start thinking about this and going and getting, reaching out to contractors.
The heat pump incentives, the tax are active now.
Oh, good. Here's another resource on Energy Star. Hopefully this is the same list as NEEP as what's eligible, but they both have lists of eligible heat models. Not all models are eligible. There is the criteria I mentioned off of NEEP is it has to be at least 175% efficient at 5 degrees to be on NEEP, and only a subset of those, the most efficient, are eligible for the credit. So these ones would be the highest performing, and also the highest performing within Energy Star as well. So just make sure if you're getting a quote, make sure that it is listed on NEEP. You get the model. A lot of times contractors won't even give the homeowner the model number of what it is. You should always insist on that, and you should always insist that it's listed there, because that's how. And you should also always insist that you're going to get the tax credit as well. I'm just going to close with some references. I think we can hopefully circulate these slides, Joy, to the attendees. Is that possible?
Yes, it is.
Awesome. This is a great article here. I think it was 2022 in Wirecutter in New York Times about this process of how to go about this process. A lot of things that I was talking about, what's a good house for a heat pump, how to get contractors, how to know that contractors are good. There is a section in here where the top manufacturers like LG, Daikin, Mitsubishi, there's links to their websites where you can punch in your zip code and you'll get a list of contractors who have been trained in their heat pumps. So you definitely want that, and people that have been certified at least by the manufacturer to be able to do a good job. And here's the NEEP database. And again, it's not 81, it's 107,000 models are eligible. Here's just more on Energy Star. And then finally, Pico does have a home energy assessment, and they do a blower door test. So if you can get one of these, if you're thinking about this, it's by far the cheapest and smartest thing to do is to get your house, someone look at your house and see if you can do the cheap, easy things to just cut the heat loss from your house.
And Steve, I'm going to interject that at my church, and I'm going to put this in the chat, this coming next Wednesday, if you attend a workshop on reducing or weatherizing your home, you can get there's going to be somebody there from Pico who you can get a free home audit. It's a $49 value. So that's without the blower door test. If you add the blower door test, I think it's $50. So I'm going to put that in the chat. So that's it. It's an excellent thing to do. And a lot of times you get, free light bulbs. When we had ours done, we got a low flow shower head, all those things.
That's great. Yeah, that's really good stuff. And finally, there's this website here, Friends of Harvard EAC. So this is a email address here. If you write to say, and you are seriously thinking about looking at converting to heat pumps, they'll contact me, Sam, and Hank, and we have worked with so far maybe about 5 or 6 different homeowners on the whole process. Like, you're getting 3 quotes, and how do I make sense of them? Is this good or is that good? Or what would make sense? What are good questions to ask them? So we are volunteering as people that have gone through this process to share our experience with you and hopefully make it less intimidating or less complicated. So please take that up if you are interested. And yeah, here's just some of the numbers for is this from you, Sam? I think this is from Peter. Just some approximate costs. No, this is Sam, I think. Right?
I don't know if I did that. Hold on. Yes, I did do that.
Okay.
You have to remember that was before inflation kicked in.
Right. Yeah. I know there's a big issue with panels here being really hard to get, supply chain, whatever, they're going, very expensive. It's a big issue, but there's other things as we hopefully got across that people can do. If one thing is hard, you could replace your lawnmower, or you could replace your gas range with an induction, or your dryer to chip away at your considerations. Make sure the contractor has valid references and experience. Make sure your house is as well insulated and airtight as what would be reasonable. And that's why I think the Pico, especially Pico, is doing these inexpensive blower door tests. You should do that. So, when we go out to houses too, we also will, look in your attic. Do you have insulation in there? That should be the, first thing to do. And here are some things that are signs of a good, well-trained technician. I think we're almost at time. More from here. This is what Sam was saying for the water heater. Where's the heat coming from? That it's dumping into the water. And solarized Delco is a great thing to think about. You can also reach them on that haveswitch@gmail.com site. And I think that's all. Here's another one. I think we went through this.
Yeah.
There
are a couple questions.
Sure.
So Michael, I'm gonna come back to yours. I'm gonna do the heat pump one first. So this is from Lucia. I have a gas furnace with radiators for heat and window AC units for cooling. Do radiators need to be removed to do the ductless heat pumps?
I would say it's a matter of space. Sometimes you might not have room because they're very often under windows where you might want to put a head. But it would make it very expensive if you're going to take out radiators, but you may want to. I don't really know if there is room or not.
Sam, what was the reason that you did the removal of the radiators?
Well, I did it mainly because when I was remodeling my house, I was doing a complete gut job of it. So I sized my house and was completely changing up the HVAC system of the house in general. So aesthetically and for purposes of efficiency, I just didn't need them anymore. So I removed them during the process of my demolition process and when I was redoing everything. So, but for everybody else who's dealing with the situation where they have radiators in their house, it really is something that's an individualized process in terms of dealing with retrofitting to do heat pumps. One size does not fit all. People learn this through hard experience, unfortunately. In Europe, they are starting to deal with systems that can replace boilers. Teseo is one of the ones that is come up and coming in Europe. But unfortunately, solutions for radiator heat in terms of electrification in the United States are not there yet. So it's a case-by-case situation, how you're going to deal with it.
Yeah. And one issue that heat pumps have is these are called air to water. So they're taking heat from the air outside in the winter and dumping it into water that circulates through your radiators. Is they can't get as hot as, or they don't get as hot as a boiler. So it's much more complicated. And the simplest thing, of course, is to take out your radiators and put in those split heads, but that turns into that's my situation in my house. But then you don't have to deal with the window units, which we all hate so much to put in and out every year. It's so difficult to do, but that's a tough situation, is to electrify a house that currently has a radiator system, which is very common here.
And Sam, how did you decide where to put your mini split?
It was for the open concepts areas where there were no wall partitions. It was just as simple. It was just as simple as putting it in the middle of the space. But when it came to my second floor, where I had multiple rooms, I had to duct in the unit to each of the individual spaces in order to make it work. I didn't use a mini split on the second floor. I used a ducted heat pump. Usually that's a small unit with an outflow that's ducted, and then you size the duct appropriately to every space. You can either do exposed ductwork, or you can put the ductwork in and soften it out, soften the ductwork and put registers up in order to make it work. So in that case, not only are you going to need an HVAC specialist, you're going to need a carpenter as well, who can make it aesthetically pleasing. I mean, I've went into one house where it was radiators. Unfortunately, the problem with this with these retrofits is that a lot of people, I know this is my little pet bugaboo, so I'll just put it out there in order for people to know, is people put a lot of work into the aesthetics of their house. They want a nice kitchen, they want a nice living room, they want to dump money into the things that are visually pleasing, but they don't save the money on their utilities. And by the time the people start thinking about, oh, I'm going to upgrade my utilities to do what we're doing here, I have to start working around people's very well prepared house that they love so much, and I'm saying, well, I want to put ductwork here and ductwork there, and they might have thought about, well, how do I deal with the paint job that I put here, or the wallpaper, or the fireplace that I put here? It gets very complicated very quickly. So if there's one thing I would say, the first thing you should upgrade, if you have an ugly house, before you start dumping money into the aesthetics, think about the guts of your house, which is your mechanicals, and start dealing with that first before you start upgrading your kitchen and all those other things. But that's just my personal opinion. You're muted, Joy.
We have several more questions. Thank you. Is it worth the cost? Did you say these costs were not including the IRA discounts, rebates? So I can just say I have an old heat pump right now, and we've gotten quotes to update it, and we have a gas backup. And a lot of the contractors around here definitely want to sell you also a gas backup. Sam does not have any backup system at all. It's all just the heat pumps. It depends on how tight your house is, and how well you think about that it's sized correctly. Another option for backup is just kind of like a toaster oven backup. But I would suggest, if you're doing that, to make sure that the controls are such that it doesn't bring that on unless you ask it to, because you might lose all your efficiency that way. But when I got my quotes, it was actually cheaper to not have any fossil fuels. So in that case, if you're going to be changing, I have a ducted house, so it was definitely worth it there. I don't know what the cost would be. And I guess, Sam, since you did the installation, you don't really know either for the installed mini splits.
You have to be cognizant of the fact that labor is unfortunately expensive. And you're going to get, from our experience, you're going to get quotes that can vary quite widely in terms of not only the equipment, but the labor cost. The one thing I would suggest is making sure you get multiple quotes. And if you need an educated team on your back, Steve and I will definitely help you out in order to flesh out the best estimate for you to make sure that you're getting the best deal. And as an aside, Steve, can talk to this more, but he does this in New York, and the units he helps to recommend do not need backups, and that this is New York, which is colder than Pennsylvania. So these units are wildly efficient, and the fact that I've gone 3 winters in Pennsylvania, even with a few polar vortexes thrown in, without a backup heat system, attests to the fact that it can be done here, and I would not be afraid to have any estimate or contractor that throws out the idea that you need a backup system, have them come over to my house, and I will gladly tell them that that is not the case, and they are behind the times.
So,
Next.
oh, could I just interject here? One thing that we also do, if you are interested in looking at this, like Sam said, is I can take your utility bills and estimate how much power your heating system needs at 10 degrees, 15 degrees. And a good number on here would be, you should be able to heat your house well at 15 degrees. And if they select a unit like that's on that NEEP list, we'll know how much power it can deliver down to 5 degrees, any of these numbers. But if they just give you a model that's not even rated like that, you have no idea how well it's going to do when it's cold for your house. So the contractor rightly wants to also sell you a big gas furnace as well. But your gas bills tell you how much power you need, and we can help you with that. And if they pick a unit that is on that NEEP list, we will know how much their units have. And as Joy said, if they put electric coil in there, maybe it comes on for a day, a year, or maybe just during a vortex, you'll be fine. You don't need this big unit. And contractors generally in the cool air conditioning side, and I think most people do with the heating side, they'll try to sell you as much power as they can get away with, because they don't want to call back on a really cold morning. But it won't operate as efficiently but it should be sized well to the house. And anyway, we can assist with looking at your bills. If it's oil, it's very hard to do that. But with gas, it's pretty easy to determine that. So I just wanted to mention that.
One easy question: can heat pump be installed that you can use for cooling the house? Absolutely, it does both. The next one that I don't know the answer to: do you recommend the combination heat pumps that heat air and water?
I'll address that. If you're talking about an air-to-air heat pump, which is primarily what we've been discussing, like Sam has, then the heat pump would be a heat pump water heater. And Sam has an unusual one where the outdoor unit is outdoor and he's taking the heat from the outdoor air. But typical heat pump hot water heaters are units that are in the basement and it draws the heat out of your basement. So I don't know if that's answering the question. There's another type of heat pump, as Steve had mentioned. It's a ground loop or a ground source heat pump. And those units have an option where you can connect up your hot water. It will actually produce hot water for your hot water heating in addition to your air system to heat the house. So I don't know if the question was directed for a geothermal or ground source heat pump, but an air source heat pump generally doesn't have that option. So you'd have to go with a standard, a standalone hot water heat pump. And typically, as Sam mentioned, you can see them in Lowe's and Home Depot or whatever. I don't know. Does that answer the question? I guess.
Next question is, Steve, how many heat pumps do you have? I'm not sure if it's Steve or really Sam that's addressed to. Steve, do you have heat pumps?
I have none that do heating. Just air conditioners.
I have 3 heat pumps, one in my basement, one on my first floor. Those are mini splits. The second floor is a ducted heat pump. The one on the first and second floor, those are both Mitsubishi brands. And the one on the second floor, which is the ducted, is a Fujitsu. They both have a SEER rating, which is an efficiency rating that you'll typically see on your air conditioner heat pump units. The one on the basement and the first floor have a SEER of around 28. And I believe the one on the second floor has a SEER of 25. I was able to get top of the line because I'm saving on labor.
And for I have one big heat pump that, because my whole house is ducted, satisfies the whole house. Next question is statement. I love my radiators. We plan to install a heat pump and some mini split heads for ductless cooling and spot heating so we can reduce radiator use. Getting rid of the radiators and attendant pipes and etc. would be significant in itself. It's too bad that there are not better solutions for electrification for radiator systems. Thanks for answering my question.
Yeah, I'm going to just make a mention of that. There are folks out there that put in these mini splits like Sam. They use them for when the temperatures are mild. They still don't want to get rid of their hot water or steam radiators. And I can appreciate that. And so there are people out there that have dual systems and they'll kick the radiators on when it gets very cold. As Sam mentioned, in Europe, it's more common that they do have heat pumps that will heat water to heat the radiators, whether it's radiant in the floor or radiators. But typically, if they're doing a good job, those radiators have to be increased in size because, as Steve mentioned, the temperature of the water is lower. So they have to have more surface area. And in fact, I saw one YouTube where the woman's apartment had 2 huge panels on her wall that were really the radiators. And it's like, well, that's pretty pretty extensive and whatnot. And I just don't understand why they just wouldn't have gone with, the airheads, because to go back to the question, if you're going with an air system like Sam's, you're going to get the benefit of cooling also. So not only will you have more efficient heating, but you're also adding value to your house that you now have a better cooling than window units, or what we would call in the industry window shakers. So, it's a more permanent and it's a quieter and a much more efficient system than window units. So, and just to mention too, like Sam had alluded, that with a lot of these cold climate heat pumps, mini split systems that are out there, there's a lot of different configuration. You can get what everybody's been referring to are the heads. There are the things that go on the wall. You'll see them. Most people now see them in all different places. You can get consoles that fit on the floor. You can get consoles, cassettes that fit into the ceiling. You can also get air handlers that go into an attic or a closet. Probably that's what Sam did for a second floor, and they get ducted like the old-fashioned systems. So you can do multiple rooms or even an entire house. So there's a lot of different configurations out there. What I would say is that's really critical too, is a contractor really has to understand heat pumps. Ductwork is critical if it's going to be a ducted system to make sure it's sized properly. Just because you have an old gas furnace sitting in the basement and you have some ductwork floating around doesn't necessarily mean you can just swap out and put a heat pump in. That ductwork is much more critical size-wise. So you really need to have a contractor who understands, but not a contractor who's going to try to sell you out of a heat pump and just put it in an old gas furnace again. Going back to the gas backup, even the member that we helped switch out from gas, one of the considerations was when you put a gas supplemental or backup in, even if you run your spreadsheets and say, well, it's going to be more economical to run, there's a hard cost of having that, not only the initial investment of the gas heater itself, and I'm talking about in addition to the heat pump, but maintenance on that furnace, even though gas furnaces aren't a high maintenance, but they have a very finite life expectancy. And there's a hard expense on that. A toaster coil or resistant coil, there's basically nothing to it. And so the trade-off is for, as Steve said, maybe you need to use it a couple days out of the year, but there's really no maintenance at all about that. And that will way outlive your unit. So to me, it's also about a maintenance and longevity, and a much simpler operating system than when you combine a heat pump plus a gas furnace. And when you do that, there's also a whole control that has to coordinate the operation of both systems, to coordinate how they fire up, and one turns off, the other turns on, and whatnot. So it's a much simpler setup, just going with resistant backup.
So we're at 8:20. That was the end of the questions. So I invite anybody, if they want to leave, to head off. And then if any additional questions, you can chime in now.
Hi, everybody. Thanks. Can everybody hear me?
Yes.
Yeah, well, you've given me a lot to think about. We have our plumbing and heating contractor that we really like, has been doing mini split units for a long time. So we're going with him. I do want to ask him for the exact model number, just to make sure that in the right thing. But, you know, so let me try to frame this, not take too long. The plan was to get one heat pump, have one large mini split head downstairs, and then have multiple heads upstairs to heat the individual rooms. But the question that this presentation has made me wonder is it possible to get, like, say a mini split head in one room and just duct that directly into the next room to do both, so you don't have so many mini split heads? Or is it too many different kinds of systems being introduced to the same things? We have no ductwork in our house, and we're not planning to introduce any. But some of these rooms literally are separated. They're adjacent. The wall. If you had the mini split on one wall, seems like it's right there. The room on the other side. So I didn't know if anybody was able to speak to that. And we could also obviously ask the contractor, but I'm curious if anybody has any.
I mean, I have a comment, but Sam or Steve, do you want to? Because I'll make a comment to it.
Well, I do my bread and butter is ductwork. So if you're willing to go with a ducted system, you have to understand that you're going to have a unit that has ductwork. I think I alluded to this earlier in the program, that you have to size appropriately and make sure that your HVAC specialist knows how to install that appropriately, because it's not just making a metal tube and going from one room to another. There is some math involved in that. So make sure your contractor understands how to do ductwork. And the question is, do you want exposed ductwork, or do you want unexposed ductwork that you're going to have to soften in? So you have to get a carpenter involved as well. So not just the HVAC specialist. That's the big thing that comes through my mind when you ask these types of questions.
I thought Michael was saying he doesn't have any ductwork and he's not considering any, right? Is that what you're going with that?
I'm not sure I explained it correctly. I don't want to take everybody's time since we're well over. What I meant, like, let's say the room that I'm sitting in right now is, we have 4 bedrooms in our house, and there's a room that's directly adjacent through this wall behind me. And it's like, if there is a mini split on the, mounted at the ceiling, at the juncture of the ceiling and the wall right there, is it possible for that one head to just be able to also cool or heat the room on the other side? No, okay, see, that's what I want.
No.
I didn't think so, but I want, because I thought it was a different type of system, right?
Yeah, I'm going to answer that, Michael. If you're going with a traditional head, you're not going to put a piece of ductwork on it. And even if you could, you're going to have those heads really are not designed, but you also have another consideration. You don't want to think about it this way. If you have a bedroom and the next bedroom, would you want to cut a big hole in the wall? Is essentially what, like, you also have a sound issue and privacy issue between one room and another. So the heads aren't designed for that. Now they do have smaller units that can have a very short duct run for 2 units, but that also should be up in a ceiling somewhere or whatever. They also have units that can go in a mini split that can go into a closet and be ducted, or even in the attic and spread out. But now you're going to have more traditional ducted system. And as Sam said, it needs to be sized out and calculated. Joy's familiar with that. But if you have the space, then you might want to consider a ducted system for your second floor, just like Sam did, and do a head for your first floor. Now, your outdoor unit might or might not handle both the head and the air handler. So you might wind up with 2 outdoor units, one for the head in the first floor and another unit for your split ducted system for the second floor, whatnot. Okay. I don't know if that helps.
No, it helps a great deal. So thank you very much for answering that. So I think, the plan that we have actually makes sense, because we're definitely not trying to add ductwork to the house.
Yeah.
There's not much space for that. And, so
Okay.
thank you guys so much. This has been extremely informative.
No problem. Any other questions?
We will circulate the slides. I think I just sent you, Joy, the slides, so hopefully we can get. There's a lot of good links in there as well.
Great. Well, thank you, everyone. Thank you, Steve, Sam, and Hank, as usual. We do try to have these workshops about 3 times a year. So tell your friends, come back to learn some more, and we wish you luck.
Okay, thanks, Joy.
Right. Thank you all. Bye-bye.
Good night.